Hi everyone, this is me, K. Shanmukha Priya, studying in Srinivasa Ramanujan Institute of Technology. Today my topic in linear algebra and calculus is triple integration. And triple integration, there will be three limits x, y, z. In the x limit, we take x as constant or in the terms of y and z. The y limit, we take it as constant or in the terms of x and z. In the z limit, we take it as constant or in the terms of y and z. The triple integral is evaluated as repeated, we can see in the PPT. And next, the limits z are z1 and z2, where it functions of x and y, and the limits of y are in y1 and y2 form, where it functions for only x when the limits are for x is x1 and x2, where these are constants. In the equation, when we can evaluate as a follow, first we have to integrate f of x, y, z with respect to z and with the limits keeping x and y constant, and then resulting the integrated between the limits y1 and y2 keeping x as constant. The result is finally integrated with respect to x between the limits x1 and x2. We can see the formula here where x1 is integrated to x2, y1 integral y2 and integral z1 to z2 limits f of x, y, z dx dy dz equal to integral x1 to x2 integral y1 to y2 integral z1 to z2 in the form f of x, y, z dz dy dx. Here we can observe that first we are doing the integral of z, y and x. And there is an example question of the triple integrals where the integral 0 to log 2, 0 to x and 0 to x plus log x, ex plus y plus z, dx, dy, dz is a question. Here first we have to integrate the z and keeping x and y as constant, where e of z integral x plus log y and 0 dy dx, and in the next step we have to substitute their upper limit minus lower limit, where ex plus log y minus e naught and e power x plus log y can be written as e power x into e power log y. And at the next step here we can observe that e power log y can be written as e power y, and next we have multiplied here and we have differentiated the y keeping the x as a constant, and next we have multiplied the here all these things. Next, after the multiplication, we have started doing the integral for the y keeping x as a constant and doing and separating it x power 0 here. And next we have solved e power 2x into e power 2x, and here at the place of y I have substituted upper limit minus lower limit, whereas x minus 0, and here at the place of e power y, at the place of y we have substituted upper limit minus lower limit and x minus 0, and here also in the place of y we have substituted upper limit minus lower limit, whereas x minus 0. And next e power 2x into x e power x can be written as x e power 3x minus e power x into e power 2x can be written as e power 3x, and e power x into e power x can be written as e power 2x, and e power x and e power 0 can be written as 1 and 1. And after the z and y integrals, we have to do the integral of the x, keep, and x is the remaining last one, and e power x can be written as x e power 3 by x by 3, and e power 3x can be written as e power x 3 by 3, and e power 3 by x can be written as e power 3 by x by 3, and e power x can be written as e power x. And by integrals of that, and next step we have to do it upper limit minus lower limit, whereas keeping the 1 by 3 at the outside, at e power x e power e at the place of x we have to keep the log 2, substituting the log 2 in the place of x, whereas log 2 e power 3, and here in the place of x we have to do the log 2 minus 0. 0 into anything becomes 0, so it becomes 0. And the 1 by 9 is taken at the outside, and e power 3 at the place of x have written as log 2 minus 1, whereas e power 0 can be written as 1. Here e power 3 log 2 minus e power 0 as written as 1, and the 1 by 3 is taken at the outside as a common, and e power x in the place of x we can written log 2 e power log 2 and minus 1. At e power 0 is known as 1, and there will come 8 by 3 log 2. By substituting the above formulas, by substituting the above equations, we can write 8 by 3 log 2 minus 8 by 9 plus 1 by 9 plus 8 by 3 plus 1 by 3 plus 2 minus 1. 8 by 3 log 2, and by doing all these remaining factors at the LCM form, all these things at the LCM form and substituting it, we will get 19 by 9, whereas the answer for the solution of triple integral of 0 to log 2, 0 to x, 0 to x plus log x, e power x plus y plus z, dx dy dz is 8 by 3 log 2 minus 19 by 9. And thank you for this.